This is mathheals.com, where you can find more links to math and computer science YouTube videos. Let's take a look at an introduction to functions. And let's first talk about what is a function. Basically it says for every x there is only one y. So for every x there's only one y. Well, let's look at our first problems dealing with that definition. We've got 1, 2, 3, 4, 2, 5, and it says determine whether each relation represents a function. State the domain and range of each relation. Well, let's do a mapping to show this. I'm going to write down my x values going from smallest to largest, not repeating any. So I got 1, 3, and 2. So I'll have 1, 2, 3. And I'm going to circle them. Different ways of doing mappings. This is how I do them. Then I'll write down my y values going from smallest to largest, not repeating any. So I got 2, 4, 5. Like that. Now this first one maps 1 to 2. So I draw a line between them. Next one maps 3 to 4. So I draw a line between them. Next one maps 2 to 5. So I draw a line between them. Now, function. For every x there's only one y. If you do a graphical view like this, you can only have one line coming out of each circle for the x's. And I see there's one here, one here, one here, so this is okay. This is a function. Now your domain and your range. Your domain is your x values. And again, you just write them from smallest to largest, not repeating any. So it'll just be whatever you listed here. So it'll be 1, 2, 3. Now for our range, that's our y values. For the smallest to largest, not repeating any. So we got 2, 4, and 5. And those would be our answers. Let's look at another one, dealing with points. So I got -4, 1, -4, 2, actually -4, -2, and 3, 1. And again, I'm going to write down my x values and my y values. Smallest, largest, not repeating any. My x values are -4, -4, and 3. So I'm going to have -4, and I'll have 3. Then I write down my y values from smallest, largest, not repeating any. So I got 1, -2, and 1. So I got -2 and 1. Now this first point, -4 and 1, that maps -4 to 1. This one maps -4 to -2. And this one maps 3 to 1. For this definition to be true, you can only have one line coming out of each circle in the x's. This one has 2 coming out of it. So this is not a function. And our domain is our x values. Our x values are -4 and 3. Again, we don't repeat any. And the range is our y values, smallest, largest, not repeating any. So this will be -2 and 1. Now, I always show this graphical view for those going into elementary education, because they'll be working with kids and kids, you know, I don't know what, K through 6 maybe. They see better with pictures like this, the graphical view. But there's an easier way. You look to see if your x values repeat. If your x values don't repeat, then it's a function. If your x values repeat, then it's not a function. See out here I got 1, 3, and 2. They don't repeat. That's why this one's a function. This one over here, see how they got -4 and -4? Well, the x values repeat, don't they? So it's not a function. So you don't have to do the mapping on the homework on these. You can very quickly look at it and see. Okay, let's look at another one. We'll use the shortcut on this one that I just mentioned. So I got 8, 3. I got 5, 3. And I got 3, 3. Now remember what I said, we look at the x values. We could care less about the y values. So if I look at the x values, I got 8, 5, and 3. They don't repeat, do they? So this is a function. And for our domain, Write them from smallest to largest, the x values, not repeating any. So I got 3, 5, 8. And for my range, I'll write down my y values, smallest, largest, not repeating any. I got 3, 3, 3, so I got 3 as my range. Now, if we had a different problem, where we had like, I don't know, x squared minus 3x minus y to the third plus y to the fifth is equal to the absolute value of x. And the question is whether this is a function or not. Well, by using that definition above, we'd plug in, like, for example, we pick x equals 1. And then you solve this and see if it gives you two different y values. We'd plug in x equals 2 and solve it and see if it gives you two different y values. We plug in x equals 3 and see if it gives you two different y values. And so on. Now, I always give this example in class. Sometimes the students look at me kind of funny, but I ask if there's anybody who's a runner. And usually I get one person. If not, I make up somebody. And I ask them if they can run 1 foot. They look at me like, what? What kind of question is that? And they say yes. And 2 feet, yes. 5,280, 1 mile, yes. And 10,000. It's too early. 560 feet, 2 miles. I say yes. Eventually, they're gonna fall over from exhaustion. Maybe at 100,000 feet, maybe at 200,000 feet. I don't know how many. The fact that they can do it for the first 100,000 or 200,000 does not mean they're going to be able to run forever. So I could sit here and I could plug in 1 million x values, and the fact that it works for the first 1 million x values does not mean it's going to work for every x value. So I could actually spend the rest of my life plugging in x values, trying to see if this is a function or not, and still not have the answer when I'm dead. Well, we want an easier definition for that. We don't want to spend the rest of our life on one problem. Now, for purposes of this class and college algebra, this definition would work probably 100% of the time. It'll start failing as you get into some of the more tougher ones if you're going on to calculus. But it says, if you have one of the following, so if you have one of the following, it is not a function. If you have a y squared, if you have y to a fourth power, or just y to any even power, it's not a function. If you have the absolute value of y, it's not a function. If you have a plus or minus square root of x, it's not a function. Now, a negative before a square root of x is okay. A positive before a square root of x is okay. We just cannot have this symbol here, this plus or minus symbol. Or more generally, you cannot have plus or minus x of any form. If you have x is equal to a number, we don't have any y's in the problem. We just have x is equal to some kind of number, like x equals 3. That's not a function. Now, you can have other items in here with this, like this absolute value of y, for example. This could be a y squared minus 3y plus 2. You can have that, but specifically you're going to have a y inside an absolute value. Let's look at these next problems. 4 says determine whether each equation shows y as a function of x. Y is equal to 2x minus 1. Plus 1. It didn't sound right when I said it. So I'll come over my list here and I'll look to see if it has any of these bad items. Well, we can have y to the first power. Y to an odd power is okay. We just can't have y to an even power. So this one's okay. This is a function. On the next one here, we got 5x plus 2y is equal to 7. And again, we can have y to the first power, so that's fine. This is a function. Here we got y is equal to plus or minus 3x. Again, we can have an extra number in there. That doesn't really matter. But notice how we have the plus or minus symbol and then x is some form. So this one is not a function. Let's see. Y is equal to x to the fifth minus 1. Well, again, this is like y to the first, so that's fine. We just can't have y to an even power. So this is a function. And number 8. We got y squared is equal to x plus 1. Well, we have a y to an even power. It cannot have y to an even power, so this one's not a function. Let me start a new page, and we'll work the next problem. We got another test whether something's a function or not. It's called the vertical line test. And it says, if any vertical line can intersect the graph at 2 or more places, it is not a function. So if any vertical line can intersect the graph at 2 or more places, it is not a function. Okay, so our 9th example here, we have this picture, more or less. Now the question is, can I draw a vertical line that can intersect at 2 or more places? Well, I can draw one right here. That would definitely intersect at 2 places. So since I can draw a line, then this is not a function. On this problem here, I have something that looks like this, more or less. Okay. Well, let me draw a vertical line here. Intersects one place. Draw one here, one place. Draw one here, one place. No matter where I draw a vertical line, the most it'll ever intersect is one place. So this is a function. Again, if you can draw a vertical line somewhere that intersects at 2 or more places, it's not a function. Otherwise, it is a function. Now the next thing we're going to talk about is function notation. It has 2 purposes. First purpose is to give a name. Let's see what we're talking about there. If I had y is equal to 3x minus 1, and I had y is equal to 4x plus 2, and I told you to graph y, well, your question would be, well, which one? There's 2 of them. So for function notation, instead of putting a y there, I can put something that looks like this. And for the instead of this y, I can put something that looks like this. Now, how you read these? This one reads as f of x. This one reads as g of x. There's no mathematical meaning here. This does not mean f times x. This does not mean g times x. This is just given it a name. So we're calling it f of x, g of x. And you pick whatever letter you want. Typically in algebra books, you see a lot of f's and g's. But if you're going in real life, you'd pick letters that made sense with what you're working with. If you're trying to find the profit, you'd use p of x. Now we even get lazier in math. Instead of writing that out, we'll just put f, or we'll put g. Now that's its first purpose, to give it a name. Now the second purpose is for evaluating. And let me show you an example to demonstrate what I'm talking about there. You saw these in an earlier math class. It would say evaluate y is equal to 3x minus 1 for y when x is equal to 2. Now if you remember how you'd solve these, you'd go through, and where your x was, you put in parentheses. Everything else remained exactly the same. And then we plug in what they want us, the value they're telling us. Telling us to plug in 2. which gives us 6 minus 1, which gives us 5. Well, instead of writing it that way, we can write f of x is equal to 3x minus 1, and then we'll say f of 2 is equal to, and I'll put a question mark. Instead of writing all these words to say that, this notation right here says exactly the same thing. To solve this, it's exactly the same steps. That hasn't changed. We're going to go through, and everywhere we have an x, we're going to put in parentheses. With function notation here, whatever is inside the parentheses is what we're going to put in over here. So we'll put a 2 in it over there. So 3 times 2 is 6, and 6 minus 1 gives us 5. So that's a second purpose for our function notation. Let me start a new page and we'll look at a problem. Number 11. We got f of x is equal to 4x minus 1. There's a lot of different parts to this one. First part, they want us to find f of 0. Well, we always solve these the same way. We go through our original function. Everywhere you have an x, put in parentheses. Everything else remains the same. The 4 is out in front, the minus 1. We just replace the x with parentheses. Now, whatever's inside the parentheses right here is what we're going to put in over here. So in this case, it's a 0, so we'll put a 0 in over here. Well, 4 times 0 is 0, and 0 minus 1 gives us a negative 1. Then they want us to find f of 3. And again, we go to our original function. Wherever you have an x, you put in parentheses, and everything else remains the same. Whatever's inside the parentheses here is what we automatically put in over here. So we're going to put in a 3 there. 4 times 3 is 12. 12 minus 1 gives us 11. F of negative 2. It doesn't matter what it is. It's still the same idea. You go back to your original function. Wherever your x is, you put in parentheses. Whatever's inside the parentheses here is what you'll put in right here. So put in negative 2 there. 4 times negative 2 is negative 8. And that carried down to minus 1. Negative 8, negative 1 gives us negative 9. F of negative x. It doesn't matter that this is something different. It's still the same idea. You go back to your original function, and where your x is, you put in parentheses. Whatever is inside the parentheses here is what you put in over here. You're going to get tired of hearing me say that. So we'll put in a negative x there. Well, 4 times negative x gives us negative 4x. And then the minus 1 carries down, and that's our answer. I think why they got so many different parts to this one is because they want to really emphasize that fact, what I keep saying. Now this one's kind of the oddball one of it, because if you look at it, what's inside the parentheses here, it's just a single x. Well, that's what we have up here is a single x. But here's the negatives out in front. So what we're going to do is put the negative out in front, and then we'll just write down 4x minus 1. So that doesn't change at all in this one. We just have to have a negative out in front of it. Now, negative out in front of your parentheses is going to flip the sign of everything inside, so the positive 4x becomes a negative 4x, and the negative 1 becomes a positive 1. And that's our answer. And then f of x plus 2. Looks a little bit different, doesn't it? But again, same idea. We go back to our original function. Wherever you have an x, you put in parentheses. I'll put a little bigger one this time. Whatever's inside the parentheses here is automatically what you put in over here. So I'll put in x plus 2. Now, a number out in front of our parentheses, we're going to use distributive property. So I'll take 4 times x, which gives us 4x. 4 times 2, which is 8. And I'll carry down to minus 1. 8 minus 1 gives us 7. So we have 4x plus 7 for our answer. F of 2x. Again, we'll go back to our original function. Wherever we have an x, we'll put in parentheses. Whatever's inside the parentheses here is what we put in over here. So we'll put in 2x there. 4 times 2 gives us 8, so with an x. and then the minus 1 carries down. And then the last one, f of x plus h. Again, we're going to go back to our original function, and where our x was, we'll put in parentheses. Whatever is inside the parentheses here is what we're going to put in over here. So let's plug in x plus h. Distributive property again. 4 times x is 4x. 4 times h is 4h. Now carry it down to minus 1. And that's our answer. Let's take a look at the next problem. We've got f of x is equal to negative 3x squared minus 5x plus 2, and we want to find f of negative 2. Now the instructions say find the value of each function. It's kind of redundant. I mean, this right here kind of tells us exactly what to do. They could just say find f of negative 2. Well, this is evaluating a function. They're always the same. You go back to the original function. Everywhere you have an x, put in parentheses. Everything else remains exactly the same. The negative 3 stayed out in front. The squared remained. The negative 5 remained. The plus 2 at the end stayed. I just replaced the x's with parentheses. Whatever's inside the parentheses here is automatically what we put in right here, which is negative 2. Negative 2 squared gives us a positive 4. Negative 5 times negative 2 is 10. And 2 carries down. Negative 3 times 4 is negative 12. 10 plus 2 is 12. And negative 12 plus 12 gives us 0. So that's our answer. And one more of those. H of q is equal to 4q squared over q minus 3. Now here the variable's different. Same idea though. We're going to actually find that the variable on the right side here, this q, that's called your independent variable. And whatever this variable would be over here would be your dependent variable. You really don't use those very much, by the way, those terms. So we're going to go through, and everywhere we have a q, we'll put in parentheses. Everything else remains the same. Okay. Now, whatever's inside the parentheses over here is what we're going to put inside the parentheses over here. Well, what's over there is a negative 5, so put in negative 5 here and negative 5 here. Negative 5 squared gives us 25. Negative 5 times negative 5. Down here, negative 5, negative 3 is negative 8. 4 times 25 gives us 100 over negative 8. These are both divisible by 4, which gives us 25 over negative 2. And that's our answer. You could also simplify it up here. We've got 4 and the negative 8. Because if this is multiplication up here, 4 times something, then you can do that. Can't do it up here. Can't do the negative 5, because there's other items here, the minus and the squared. And I believe that's the last problem. So I guess stop the recording, and we're done with that lesson. Excuse me.